Okay, algebra, it is May 14th, 2020. I'm going to start putting the time that I make the video on here. 11:06 in the morning. The second lesson for this week is how it's a review, how to solve systems of equations, but on this assignment, let me show you the assignment. We're not going to tell you which method to use. You're going to have to figure that out on your own, obviously with some help from us. So let me explain how you could tell which method to use. Over the last 3 weeks, we have covered all 3 methods. The reality is there's actually more methods that you learn in future math classes, but for first year algebra, graphing method, that's where you graph the 2 lines, see where they cross. Substitution method is finding where they cross, but using a much more algebraic technique. And an elimination method, let's talk about that one first. It's the easiest one to tell. So how do you know that this is an elimination method problem if we don't tell you? Yeah? Because everything lines up. The equal sign, the x's, the y's, so it lines up for you. You could tell. And also you could tell because you got negative 2y and positive 2y. So something is going to eliminate right away. Bam. Yeah? Divide by negative 1. Get x equals 3, blah, blah, blah. And you plug it back in. This one, everything lines up. So you could tell it is an elimination method problem, but nothing eliminates. So you'll have to multiply everything in the bottom equation by negative 4. Yeah? Because that'll make that a negative 8, and then the x's will eliminate. So real easy to tell. If everything lines up, if all terms line up, then you know it's going to be elimination method. Let's talk about graphing method next. This is also pretty easy to tell. So in both situations, you got y equals, y equals. Y equals, y equals. So if both equations are in y equals form, or slope-intercept form, or intercept form, whatever you want to. The name of the form isn't important. What's important is that the y is by itself. If the y is by itself, it's ready to be graphed. Yeah? Let's talk about why I would not use substitution method for this. See how these both have y equals, y equals? So the reason why I would use substitution method on this one, but not on this one, or this one, is because look how large these numbers are. So you could graph it, but the y-intercept is positive 15, the y-intercept here is negative 21, so it would be very difficult to graph because the numbers are so large, and this happens often in story problems. In story problems you have very large numbers or decimals sometimes. So definitely substitution method, even though both equations are y equals, y equals. This one, even though I am a teacher of math and I'm really good at fractions, I would not use substitution method on this unless I graph this line and the place where they cross is not, if x and y are not integers, if they're like decimals, clearly decimals, then you would use substitution method. But if you graph it and it clearly crosses at a nice point, then you use graphing method. Yeah. So let me go ahead and do that one real quick, just as a review, just to show you what I'm talking about. Positive 1, 3/4, 1, 2, 3, 1, 2, 3, 4. 1, 2, 3, 1, 2, 3, 4. 1, 2, 3, 1, 2, 3, 4. 1, 2, 3, 1, 2, 3, 4. Remember, when you're graphing, the more the more points you have, the better. It makes it easier to actually graph it without a ruler or something. And then -4 is the y-intercept here. Remember, the y-intercept is where you start. That's why I'm making that point the biggest point, because it's the most important point. -1/2. So this line should go down. 1, 2, 1, 2, 1, 2, 1, 2, 1, 2, 1, 2, and there's the point of intersection. So clearly, let me see what I'm saying? The more points you have, the easier it is to graph the line. Because then you're just connecting a dot to another dot. Connect the dots. Yeah. There. So the solution is clearly -4, -2. Sometimes the solution is called point of intersection, by the way. So, but let's say I graph the two lines very carefully, and they end up crossing not at an integer, like it's going to be a decimal. Then in that situation, substitution method is the better method. Let's see, what else? This one, easy to graph. Yeah. So if you don't have graph paper though, then you might want to watch my video, or watch the video on how to turn 2 sheets of regular notebook paper into graphing paper. So again, the numbers are relatively small. Number one, both equations are y equals, so they're ready to be graphed. Ready to be graphed. Yeah. I'm gonna do the first one. Positive 3. The slope is 1. 1, 1, 1, 1, 1, 1, 1, 1, 1, 1. I know it's overkill. I don't know if I need this many points, but like I said, the more points you have, the better. And for me, for some reason, I have a much easier time drawing lines that are going up, have positive slope. -1 is the y-intercept here. -3, 1 is the slope. -3, 1. -3, 1. 3, 1. 3, 1. 3, 1. If your points don't line up perfectly, you did something wrong. So again, the point of intersection is clearly an integer, -1, 2. The graphing method works well if you have graphing paper. Now the truth is, on this one, I would say 99% of teachers would not use graphing method for that. We would use substitution method because it's just much quicker. Watch this. X plus 3 is equal to -3x minus 1. Add 3x to both sides. Yeah. Subtract 3 on both sides. Look at that. Look how fast I found that x equals -1. Which is what we got with graphing also. So it doesn't matter which method you use. You're going to get the right answer no matter what method you use. But certain methods are way more efficient. So even though I have this one in the graphing method category, column, I'm going to put it right in the middle because the reality is I would probably use substitution method to solve it, especially if you don't have graph paper. Alright, this one, why is this the substitution method problem? Because if one of the equations says x equals or y equals, then it is substitute ready is what I'm going to call it. So these are graph ready, ready to be graphed. These are substitute ready. So if we tell you what x is equal to, voila, x is equal to 3y minus 8, then you are allowed to replace the x. Remember, replace means substitute. Substitute means replace. And then solve from there. This one has a y equals. So you're allowed to replace the y in the second equation with 6x plus 3. So just like that, bam. It's very quick to do the substitution and very quick to find one of the coordinate point answers. Again, this one, the reason why you want to use substitution method on this one is because the numbers are so large you would not want to graph it. So recap. All three terms line up, use elimination method. If at least one of the equations has x equal or y equals, then it's ready to be it's ready for substitution. If both of them have y equals, and the numbers are large, then you use substitution. If both of them are y equals, and the numbers are small-ish, and you have graph paper available, then you could use graphing method, or you could use substitution method. And if there are fractions involved, and the numbers are small, graphing method is the most appropriate and probably the most efficient method. 99% of the time. Oh, 11:18. I cannot believe that I spoke for 12 minutes on that. So, anyway, so on the assignment, the first thing you want to do is go write down which method is best. What method are you going to use? Graphing, elimination, or substitution? Right, what method you're going to use, and then use that method. What method is best? Graphing, substitution, or elimination. Write down what method you're going to use, and then use that method. Yeah. We on page 2 we provided a couple coordinate planes for you to use just in case you wanted to use graphing method. We're not going to tell you which one to use, one or ones to use graphing method on. I think I gave it away. Whoops. Anyways, good luck. Due by tomorrow midnight.